Level Breakdown is a tool that allows you to visualize and organize all the interactions in your game inside Unity. With it, you can quickly see where NPCs, enemies, objects, and much more are, and even track data such as economy and gameplay time in each level and throughout the entire game. It was developed to provide developers with as much information as possible about each level of their game, with minimal maintenance required to keep that information updated within the engine. And this will be our tutorial video where I'll introduce you to the tool and show you how to set it up and use it in your Unity project. Level Breakdown is a tool made by game designers for game designers, but it's useful for the entire development team. It organizes and centralizes project information, reducing the need for external spreadsheets and making it easier to analyze game progression. 101. With it, you get quick estimates of intensity, duration, and resource economy for levels and for the entire game. Easy and intuitive access to game scenes for the whole team. An organized list of registered interactions and levels, with direct links to corresponding documents. Instant location of interactions within the scene and the project. Tracking of interaction usage throughout the game. Player learning curve projection. And custom chart creation thanks to integration with draw charts. Level Breakdown was initially designed for linear games, but it can be easily adapted to various genres with a few abstractions. So let's get started. First, you need to import Level Breakdown into your Unity project. Do this through the Unity store or directly via Unity's package manager. Now that the tool is installed, we can begin the initial setup. The first thing you should do is open the window, Tools, Level Breakdown, Breakdown window. This is the window that will display all the reports and important information the tool has to offer. At first, it will be empty because it requires some initial configuration. So let's do that setup now. 208. The first time you initialize Level Breakdown, it will automatically create several important files that you need to configure to start viewing the information. So let's locate those files and set them up. Go to Assets, Level Breakdown, Scriptables. The first one is the category data. This scriptable object is responsible for grouping different types of information into categories that make sense for your project, such as enemies, rewards, and NPCs. The first time the category data is created, it comes with some default suggestions that you can use or freely customize. The initial options are objectives, activities, bosses, enemies, hazards, and rewards. You can easily add a new category by clicking the plus button or remove one by clicking the minus button. So let's add some new categories for our project. Weapons, system, and food. These should be enough for our example. Remember that each category must have a unique name, no duplicates or empty values. If any of these conditions aren't met, you'll be notified and help buttons will appear so you can fix your category list. Feel free to reorder the categories in the list. This will directly affect how they are presented in the Level Breakdown window later on. In the Category Data's contextual menu, you'll find some useful functions to help manage it. The first one is Remove Duplicate Values, which deletes any duplicate entries in the list. Then there's Remove Empty Values, which deletes empty fields. And Reset Default Categories restores the original defaults. Important. For the tool to work correctly, you must only have one category data in your project. Once you've created the categories you plan to use, we can move on to the next step. With the category data configured, it's time to register your first interactions using an interaction data. This file stores all the default information of an interaction, allowing the tool to analyze and organize data throughout development. To create a new interaction data, just right-click in the Project tab and go to Create Level Breakdown Interaction Data. Or you can simply duplicate one of the existing interaction data files in your project. You can also use the Interaction Data Creation window via Tools, Level Breakdown, Interaction Data Creator. This gives you a support window that makes it easy to create large numbers of interaction data files. So let's create the interaction data we'll use in this example. As you can see, I've already separated some interactions I plan to use in this demo game. To help with that, I'm using the Polygon Prototype Low Poly 3D Art by SYNTY, a great low poly 3D asset pack that you can use for prototyping your game. I'll be using it to build this tutorial. Let's start registering our first interactions. The first one will be an NPC interaction. The minimum required to create an interaction is a name and a valid category. So let's register it, NPC, in the Activities category. Besides the name and category, another useful way to identify your interaction is by assigning an icon to it. If you don't want to create custom icons for every interaction, no worries. I'll be providing a free icon pack with over 120 options that you can use freely while using Level Breakdown in your project. The link to this icon pack will be available in the tools documentation. Back to creation. Optionally, you can add a short description to your interaction. Below the description field, there's an optional field where you can link to supporting materials, such as the GDD page, for example. Finally, you can configure the basic values that the interaction represents in your game. Intensity represents an abstract value of what the interaction offers the player. A value of intensity, tension, challenge, or difficulty, indicating how impactful it is. You can use positive values for things that increase gameplay intensity and negative values for those that reduce it. In my case, this NPC is a character that needs to be escorted, so I'll assign a symbolic intensity value that this interaction represents for the player. These values should be defined together with your team and compared with other interactions. A regular enemy might have an intensity of 10, while a boss could have an intensity of 50. As I mentioned before, these values are abstract and only represent a scale created by the team during development. Time indicates how long, in seconds, the interaction costs the player during gameplay. Positive values show how much time the interaction takes, while negative values can represent how much time it saves the player. So I'll symbolically add that rescuing an NPC costs, on average, 20 seconds of gameplay time for the player. To determine this value in your own project, I recommend doing some playtesting. Face enemies, overcome challenges, rescue NPCs, basically, go through your actual gameplay while timing each action. That way, you can extract baseline values for your game and link them to your interaction data. With these values in hand, you'll have a solid reference to help you create new interactions or adjust the ones that already exist. The experience value represents how much XP the player receives when performing that interaction. Likewise, currency represents how much in-game money the player earns through that interaction. Keep in mind that the only required fields to create a new interaction are the interaction name and a valid category. All other fields are optional and depend on the needs of each specific interaction or project. Once you've filled out all the values you consider necessary, you can click the Create button to generate the interaction and close the window, or choose Continue Creating to clear the fields and start another one from scratch. I'm going to use that option so I can keep adding more interaction data. Now that we've finished creating our interaction, you'll notice that a file has been generated. It's stored in the scriptables/interaction data folder using the default naming convention, category name, interaction name, and the suffix interaction data. This naming convention is not mandatory for the tool to work, but it's highly recommended to keep things organized and consistent. Alright, now I'm going to create the rest of the interactions we'll use as a foundation for building our sample game. Depending on your project, you may need to register a movement interaction, because in most games, moving around the map is what consumes the most player time. And having that recorded will help you get more accurate estimates for how long your game actually takes to play. Perfect. Now we have all our interactions registered. Just like the interaction data creation window, each interaction data file contains all the editable fields so you can update values at any time. Keep in mind, if you decide to change the category of an interaction data file, a prompt will appear asking whether you want to rename that interaction data or not. If you choose to rename it, the system will follow the same naming pattern we mentioned earlier: category, interaction name, and the file type. If needed, you can also trigger this renaming manually via the context menu on the interaction data. The system will automatically adjust the file name for you. Just a reminder, the available categories are the same ones defined in the category data. Here in the interaction data, you also have a quick access button that takes you directly to it. Additionally, the interaction data includes a shortcut button to the documentation link, which opens directly in your browser. All interactions must have a unique name. If you accidentally use the same name as another interaction, a warning will be displayed in the editor. Also, keep in mind that level breakdown is a standalone system. Changing these values does not directly impact how the interactions behave in your game project. This tool was designed to be flexible and independent, so it can be added or removed at any point without interfering with your actual game development. However, if your team chooses to create a custom integration between our tool and your game systems, for example, to speed up the process of changing values when things like intensity, duration, XP, or currency are already configured elsewhere, the tool allows for that integration. As you can see, the interaction data script contains various properties that give you access to the editable fields, so you can both read and modify them. This makes system integration entirely possible. Our recommendation is that your game systems update the values in the interaction data, not the other way around. Level Breakdown was built as an editor tool, not as a replacement for core game systems. This ensures the tool remains a flexible support system for analysis and doesn't become a rigid part of your game's logic. With all your interactions properly created in their respective interaction data files, it's now time to link those interaction data assets to the objects you'll be using to actually build your game. Since I'm using prefabs to represent each of the interactions found during gameplay, I'll be doing the integration inside this demo scene I created, and afterward, I'll apply it to each prefab individually. To integrate the data, we use a component called Interaction Object. By adding an Interaction Object component to a game object or prefab, you'll see some new available options. Right away, you'll see a preview showing all the info the interaction object is pulling in. Right now, you'll notice everything is blank: no name, no category, no intensity, duration, XP, or currency. That's because the interaction object hasn't been linked to any interaction data yet. Once you reference the appropriate interaction data, in this case, the one for checkpoint, the preview will update to show the icon, name, category, intensity, duration, XP, and currency based on the values already configured in that interaction data asset. Another required reference is the scene data, which we'll talk about in more detail later. In addition to the basic interaction data reference, the interaction object also offers options for multipliers and overrides. Multipliers let you adjust values from the interaction data in contextual scenarios. So, if this instance is in a level where something modifies the values, you can tweak them with multipliers or overrides. Let's look at a better example. Here we have an interaction object for a machine gun enemy. As you can see, a single instance of this enemy has intensity 10, duration 20 seconds, XP 10, currency 10. If you change a value like quantity, it's possible to multiply all of these stats by that quantity. You can also apply individual multipliers to intensity, duration, XP, and currency separately. This means you can scale each value independently, even using decimals or negative values. All of this is designed to help you customize each instance of an interaction within the scene. Overrides, on the other hand, are used to completely replace the configured values, both from the interaction data and the multipliers. So you can input absolute values to override whatever is already there. Any field that has an override applied will be highlighted in yellow in the interaction object preview. Both multipliers and overrides are there to help make the information more accurate. However, it's important to note that they are not required to benefit from the tool. You and your team should evaluate how detailed your data needs to be. The important thing is to have a flexible workflow. If you decide not to use multipliers or overrides, the implementation of the tool becomes much smoother and friendlier for the whole team. So, I recommend using multipliers and overrides only when you really need values that are much more precise than the default. Otherwise, we should only use them when the context drastically affects the values. For example, 100 enemies in an arena is a very different challenge from 100 enemies in an arena surrounded by explosive barrels or in a very narrow corridor. So let's revert our multipliers and overrides back to their default settings. For that, you can use the context menu options, where you can reset multipliers and overrides automatically. This context menu also offers options like auto-reference of the scene data, which we'll cover later on, and the set gizmo icon, which allows you to assign the interaction icon to the object's gizmo. This same function is also available here in this button, where you can see your interaction icon. When using it, the system will ask where you want to link that gizmo. I'll choose to assign it to a child object, but you can also assign it directly to the object itself. That way it gets referenced automatically. Assigning it to a child object allows more flexibility for positioning it exactly where you want the gizmo to appear. Now we know we need to do this for several files. In addition to the gizmo reference button, we also have the button that opens the Interaction Finder window, which we'll go over in more detail soon. Alright, now that I've referenced the interaction data box on my prefab, I'll do the same for the other activities. Give me a minute. Done. All my objects in the scene now have an interaction object and their proper interaction data assigned. As you can see, I forgot to assign the gizmo to all of them. One way to quickly apply this to multiple objects at once is to go to Tools, Level Breakdown, Interaction Object, set all gizmo icons, and choose to reference them on child objects. Done. All of my objects now have their gizmos referenced. I'll just slightly adjust their height. There we go, now all my scene objects are properly configured with their interaction objects. I'll apply these modifications directly to their prefabs, so I can reuse them to build our game without needing to redo the setup. Now let's create a scene and start building the levels of our game. I'll make a small level to use as an example. Give me a few minutes. Done, I think it's good enough. As you can see, I created a very small level here simulating an action mission. The player needs to rescue an NPC, deal with enemies, collect items, get to the getaway car, and escape. And the game is saved. Once we have all our objects positioned in a created level, everything works just like in a regular game development process. You can see here that we're using objects we've already set up with interaction objects. They're all in the scene now, so we need to register this scene in the system. For that, we need to use a scene data. Scene data assets can be found in Level Breakdown, Scriptables, Scene Data. As you can see, there's already a blank scene data asset, But since I already have a created and active scene, I'll use the option tools, level breakdown, scene data, create new from current scene. This will instantly create a scene data asset named after my current scene and automatically reference that scene. The only required fields in a scene data asset are the scene reference and the level name. When you assign a scene, the level name will be filled in automatically based on the scene name. The scene name doesn't need to be the same as the level name. Besides the scene reference, there's also a list of extra scenes. This list is only used when you have subscenes or additional scenes that load together with the main level scene for it to work properly. This helps the system load all necessary scenes when opening the level. So if you have this kind of setup, you should list those scenes as extra scenes. Otherwise, you can ignore that field. Next to the name, there's a field for the level cover. Here, you can assign an image to represent your level and help with identification. It's not mandatory, but recommended for better usability. So I'll take a screenshot of my level, find a good camera angle, and to help with this registration, I'll use the Recorder plugin from the package manager. Of course, you can use other methods to capture an image of your level, such as using concept art or simply taking a screenshot of your development view. So go to Window, General, Recorder, Recorder Window. I'll configure it based on what I need and take just a single screenshot. To keep things organized, I'll store these screenshots inside a Level Images folder within the Level Breakdown folder. We'll hit play and take a screenshot. And here it is, the screenshot of our level is done. Now let's go back to our scene data. I'll delete the template scene data and in the death pool scene data, I'll assign the new image. An alternative way to assign the image is to add _cover to the end of your image name. If an image exists with the name of your scene followed by _cover, the system will automatically reference it. To make this easier, you can use the File Name tab in the Recorder to set how your files will be named. That way, when you take a screenshot, the scene data will automatically assign it. Just like with interaction data, here we also have a field for a documentation link, where you can include a link to an external site or documentation related to the level. Below that, we have the Zones area, where you can list all the subareas contained in this level. The Zones tab is optional. I recommend using it only for very large levels, or if your project needs a high level of game design detail. Levels with zones will generate reports with information broken down by area. In my level here, just for demonstration purposes, I'll divide it into 3 parts. The initial area, the pool area, and the final area. So I'll add those fields to the zone list and name each of them. This example level is very small, but I'll still divide it into zones for demonstration purposes. Just like previous lists, you can't have duplicate or empty values. Otherwise, you'll receive a warning at the bottom of your scene data. Below the zones, we have the level overview fields. As you can see, these are estimation fields for intensity, time, XP, and currency. But they are currently empty. That's because the tool hasn't scanned this level yet. As you can see in the warnings just below, it asks for an update values to be run and for this scene data to be added to the scene list. Next to the level image, you can see 4 quick access buttons. The first one opens the scene and any extra scenes referenced in the scene data. The second button opens the link referenced in documentation link, launching it directly in your browser. The third button will open this scene data directly in the Level Breakdown tab of the Breakdown window, which we'll see later. And finally, the last button opens the scene list. As you can see below, we have 2 warnings indicating that to access this level's information, we need to run update values and add it to the scene list. Additionally, in the context menu, you have access to options previously shown, like Clear Zone List, which clears the zones if they exist, Force Dirty, which forces this scene data to be marked as modified, and Load Level Image by Name, which forces image reference based on the scene name. You may also notice that on the upper left area, there is an X next to the level's image. In the future, this X will be replaced by the position this level occupies in the scene list, representing the chronological order of that level in the game. Alright, with everything ready in the scene data, we can start configuring the scene list. The scene list is a scriptable object that stores the list of levels that should be registered with the tool. Here are its configuration fields. The first one is the game cover, an image that represents your game. This is completely optional. For now, I'll leave it with the default option. Right below it, we have the record levels option, where you'll list the scene datas of the scenes you want the tool to analyze. You can use support buttons to help fill the scene list, like Add All Datas, which will add all scene datas in the project, first asking whether you want to clear the list or just add the missing ones, and Clear Scene List. Both options are also available in the context menu of the scene list. Just like in previous lists, you can't have duplicate or null values. If you do, warnings and support buttons will show up to help you fix the issues. Well, with only one level, it doesn't really make sense to work with the scene list and the tool. So I'll create a few more example levels so we can see the real results the level breakdown can provide. Give me a moment. Done. Now we have a few scenes to work with the tool. I've created a few different scenes, just for illustrative purposes. Now that the scenes are created, let's register their scene datas. In cases like this, where the scenes already exist and we want to create multiple scene datas, one for each scene, we can select each scene we created and go to Tools, Level Breakdown, Scene Data, Create New from selected scenes. As you can see, all the datas have been created. Since I had already taken a screenshot of each level and added underscore cover to the file name, all of them already automatically reference the scene image and name. Only the zone setup is missing. Let's do that quickly. Very well, scenes created, scene datas configured. Now that we've created the zones, we need to configure the zones inside each of the scenes. So, looking at an object with an interaction object, we can see that it now references a scene data. This means the reference was automatically made in all elements of the scene to a scene data that has the same scene assigned. Now we can start using the zone feature. We can see a slider that lets us switch between the zones. Here, for example, we have Zone 0, which is Street 1, and Zone 1, which is Street 2. Keep in mind that zone configuration is optional. If you don't think there's a need to segment your level into smaller areas, you can skip this step. Currently, the tool doesn't support multi-selection for editing interaction objects, but if you need this feature, you can switch the inspector to debug mode, which will let you see and manually edit all the fields. This way, it becomes easier to edit multiple interaction objects at once. One important point we mentioned earlier is that one of the main ways players interact with your game is by moving around the map. So it's important that we record that movement time so the level's time estimate is accurate. In my case, most of the pieces I used to build the floor are made of tiles. So in cases like this, you should place the interaction object directly on the tile and specify how long the player takes to cross it. This way, the estimate will be calculated automatically when building the map. But it's quite common in more organic levels, like the Dark Forest I built, or in other types of projects that you don't use tiles to build levels, or the player doesn't necessarily walk across each tile, which harms the estimation. For those cases, I recommend creating an empty object in your scene and placing a movement interaction object on it with a manually defined value. You can calculate how long it takes the player to cross X square meters and then compute the area of your level. Or you can simply do a run, walking through the level from one end to the other without challenges, and then just input here how long that walk took. That way, you can make a more accurate estimation while still using the level breakdown tool. Done! Our levels are now perfectly configured. Each one has its zone setup. We've used the interaction prefabs created earlier, and each already has its corresponding scene data. As we've mentioned, for scenes to be registered in the tool, they need to be added to the scene list. So let's go there and add all the new scenes we created. It's important to mention that the order in which the scenes appear in this list is the order the tool will consider as the chronological order of your game. So organize them to reflect your game's actual sequence. The level breakdown tool is designed with linear games in mind, where the level order matters and is followed. However, nonlinear games can still benefit from the tool. With some abstraction and adjustments, it's possible to extract valuable insights from the tool without worrying too much about linearity. Perfect, back to our scene list. Remember, you can only have one scene list per project. Recapping, we configured our category data, created interactions based on the created categories, referenced them in the interaction objects inside the scenes, set up their zones, created a data file for each of the scenes, and added them to our scene list. Now everything's ready to start seeing the results. Don't worry, the path up to this point might seem a bit long, but this was just the initial setup of the tool. From now on, you only need to worry about creating new interaction data or new scene data as new interactions and levels are added to your game. After a few development stages, you'll rarely need to maintain these kinds of files. So let's check out the results. Now that everything is set up, let's start enjoying the benefits of using level breakdown. Let's first take a look at the interaction finder, which we mentioned earlier but couldn't use until now. So, in any of your interaction objects, you'll find a button to open the interaction finder. Or, if you prefer, go to the Tools menu, Level Breakdown, Interaction Finder. The Interaction Finder is a tool to locate interactions. With it, you can find any interaction present in the currently active scene. As you can see, the moment we open the window, it already lists all the interactions present in this level. You can see the icon of each one and a list of all of them, organized by zone and category. The list items are buttons. Clicking on them will take you directly to the object in the scene. It will be highlighted in the Scene tab and in the hierarchy, and also opened in the inspector, making it easy to navigate between the registered objects. Additionally, if you're looking for something specific, there are two ways to locate it. You can use the filters, or you can open the interaction finder directly from one of the interactions in the scene, by selecting it in the hierarchy and using the interaction finder button in the inspector. That specific interaction will be opened in the interaction finder with the filters already set for it. You'll quickly see how many of that interaction exist in the scene. In my case, there's only one, the same I selected. But if I select a more common object, like an enemy, I can see it exists in both zones with 3 instances in each. You can also filter in other ways, such as by zone, so you can choose to display just one zone or one category, like enemies only. The same goes for interactions. You can filter exactly which interactions you want to see. With the interaction finder, it's very easy to find what you're looking for. Use this to your advantage by associating interaction objects with elements you frequently look for. Perfect. Now let's go back to the breakdown window. So press Ctrl plus F12 or go to Tools, Level Breakdown, Breakdown Window. Here we are. You'll notice it's divided into 5 tabs: Game Progression, Game Breakdown, Activities Overview, Play Learning, and Level Breakdown. An interesting detail about all the breakdown tabs is that each one gives you quick access to the Update Values window, a button to open the scene list, and a button to open category data. making it easier to navigate between the tools files. Now you can see there's content appearing in this tab, but it's still empty. That's because we haven't made level breakdown scan the levels we just created yet. To do this, whenever you make a relevant change, go to Update Values. In this window, you can select which levels you want to update. You can filter levels by name or select them individually from the list. You can also use shortcut buttons to select specific scenes. We have buttons to deselect all, select the current scene, and select dirty scenes. Remember, dirty scenes are scenes that the system automatically identified as changed. This happens when a scene data is considered dirty. What makes a scene data dirty? Any change in an interaction object in the scene or an interact data can mark that scene data as dirty. This tells the system which scenes need value updates. Some scene changes might go unnoticed by the system, like deleting an object with an interaction object component. Because of that, it's recommended that whenever you change a scene, you run an update values, at least for that specific scene. If you can't do that right away, go to your scene data and use the Force Dirty option to make sure that scene data will be flagged as dirty. That way, the next time you request an update, it will be included in the dirty scenes list. When selecting all scenes, you'll get a time estimate. Right now, we don't see any estimates because we've never done a value update before. These parameters are generated from your updates. So the tool will scan the entire system and gather metrics to estimate how long future updates will take. Once you do your first update, both the time estimate and those metrics will be recorded and can be used as reference for future updates, helping you estimate how long it takes to perform a full system update or just a partial update. Once you've selected the scenes you want to update, just click Check Errors. If no errors appear, the Update button will become available, so you can trigger the update. If any errors do appear, follow the instructions to resolve them and run Check Errors again. Common errors are documented and usually involve duplicate names, null references, or unnamed zones, issues we mentioned earlier when setting up our files. Let's run a system update. Done. 5 levels have been updated. So what just happened? The tool quickly opened the 5 scenes we had set up, scanned all interaction objects, and computed all the data, taking into account multipliers and overrides, and recorded the results in each corresponding scene data. At this moment, a persistent data file has been generated, storing all global information such as total game time and the time it takes to run an update like this. And in each scene data we created, the information was recorded, including estimates for time, intensity, XP, and more. Now we're truly ready to take full advantage of the tool. We can now look at each of the tabs and see what they offer. The first one is Game Progression, a tab dedicated to providing a more summarized and straightforward overview of the game. Here we have 2 sections. The first is the Level Progression Charts, which is a collection of graphs that show estimates for intensity, time, XP, and economy, allowing you to compare levels. Here in the intensity chart options, we can see which level has the lowest intensity, the highest, and the average intensity across levels. It also provides a graphical demonstration of how the levels in our game are laid out. We can see that the first level has the lowest intensity and the last has the highest, with an average intensity of 84 across the levels. The interpretation of this graph will vary from project to project. Generally, intensity should increase, but it's normal to have peaks and valleys to create contrast and generate the desired emotions in the player. Evaluate this graph in comparison to your game and see if it matches your expectations. Check if intensity increases where you want it to, if it's increasing enough, or if not. This can be an important tool to help you make decisions and verify that the values you've assigned to your interactions are correct, and that the intensity curve for your game is following the pattern you desire. Now, let's take a look at the time graphs. In the time options, we have the total estimate for the game. For the model game I've developed with these 5 scenes, the total gameplay time is around 30 minutes. It's important that you perform a playtest and validate if, initially, these estimates are correct. From there, you'll know if the values you've assigned to your activities are accurate, and you can use these values with more confidence moving forward. Additionally, we can see which level is the shortest and which is the longest, along with the duration of each one. We can also see the average time a level typically lasts. These are very relevant insights that will help you throughout your project's development. We also have a cumulative time graph, where we can see the total gameplay time for each level, considering the accumulated time of previous levels. This helps us understand, for instance, how much gameplay the player has completed by the time they're in the middle of the game. Now let's move to the experience graphs. Similar to the time graphs, we have the total experience distributed throughout the game, the level offering the least amount of experience, the average experience per level, and the level offering the most experience. We can also view a cumulative graph to see how much XP has been offered to the player up to a certain point in the game. And similarly, we can track the game's economy, showing how much money has been offered, which level offers the least, the average money offered across levels, and the level that offers the most money. We also have the cumulative graph for this. The second part of the game progression is the levels progression overview, where we can see the number of levels recorded, search for levels by name, view the order of levels, and see the values for each one in terms of intensity, time, experience, and economy. Additionally, there are icons that indicate whether a level is above, below, or on average compared to the overall average for these values. We also have quick access buttons for levels, many of which we're already familiar with, like the Scene Data Access button, Scene Access button, Documentation Link button, and the button that takes us directly to the Level Breakdown tab, which we'll explore shortly. Now let's talk a little about the Game Breakdown. The Game Breakdown tab lists all interactions recorded in the interaction data, organized by category. This allows for viewing both individual information and averages based on each category. It also serves as a summary of all the interactions that have been recorded, allowing designers and the rest of the team to get an overview of everything in our game. Here, you can quickly see how many interactions have been recorded, and if needed, you can use the search field to find interactions by name. You can also collapse the categories to quickly view the interactions you want to check. Within each category, you'll find a list of interactions in alphabetical order, showing the number of interactions and their key data, such as icon, name, description, intensity, time, XP, and economy. There are also shortcut buttons to directly access the interaction data or open the link to the reference document. You can also track the average icons to see whether the values attached to each interaction are above, below, or on average based on the category's interactions. Additionally, there's a quick link to the Interaction Data Creator window in case you want to register new interactions. The Game Breakdown has great potential as a summary for the team, allowing everyone to check the interactions in the game in a broad manner and quickly access the link to the document for each interaction. This is probably the favorite tab for programmers. The Activity Overview tab provides detailed information about the distribution and use of interactions throughout the game. This allows you to gain valuable insights, such as identifying whether an interaction is being used correctly, locating levels that contain a specific interaction, or calculating the average instances per level for each interaction. The Activity Overview is divided into two parts: the Game Interaction Overview and Interactions in Levels. In the first part, we have the Activity Usage Overview, a graph where we can compare the usage of each interaction throughout the game. For example, we can see that the most used interaction throughout the game is movement, as we predicted earlier. It's also possible to compare activities and check if any activity is underused or overused. In the Category Overview, we can see the distribution focused on categories, showing how many interactions of each category were used in the game, their average usage per level and per zone. Now, moving to interactions and levels, this is definitely one of the most interesting parts of the level breakdown, as it offers a very broad and general view of where everything is in your game. You can easily locate which levels are using a certain activity and where these activities are in each level. On the left side of the tab, in the Game Active Overview list, you get an overview of the game, seeing how many levels are registered and, divided by categories, how many interactions from each category are being used in the game, their average usage, and individually how much of each one is being used, both in total and on average per level. Additionally, you can easily filter an interaction to only display levels that contain that interaction. For example, here I can filter all the levels that use ladders. We can see that 3 of my 5 levels use ladders. Or we can check how many levels have bombs. 4 out of 5 levels have bombs. This allows you and the team to easily locate the levels you're looking for based on the interactions. Imagine the art team searching for levels that feature landmarks or a specific type of environment. Or the programmers looking for levels with a specific enemy they need to debug. In addition to the filter options, we can quickly toggle between filters and viewing without them. In this example, we created a game with just 5 levels. However, it's normal to exceed this amount. After you have more than 10 levels, the pagination system starts to work. Let's add some duplicate scene data just to illustrate how pagination works. Perfect. Here we added some repeated levels just to illustrate how pagination works. As you can see, when I reach the 10th level, I can't continue, and a preview of the next level appears with reduced opacity. To go to the next page, just click this button. Or if you prefer, you can switch to expanded mode, where the page is removed, and you can navigate freely through all the levels. The page will be divided into batches of 10 levels, making it easy for you to find them based on that value. Now let's clear our scene list to go back to the original levels. There we go, we're back. Just like in the Game Breakdown tab, it's also possible to collapse the categories you don't want to view here in the Active Overview. The Player Learning tab simulates the player's learning progression throughout the game. This tab is especially useful for linear games where the order of the levels is predictable, allowing for a more precise analysis of the introduction of new mechanics and concepts to the player. Right from the start, below the learning overview, we can see the new concept introduction chart, which is a graph showing how many new concepts are introduced to the player in each level. This allows for the analysis of how much new information is presented to the player at each level. Right below that, we have the learning curve chart, which simulates the learning curve by cumulatively showing how many new interactions the player has encountered in each level. This way, it's possible to see learning spikes or valleys with no major new content and always try to bring freshness to the player's experience. Below, we have a full list of all the interactions. On the left, you can see all the interactions that are recorded, and right next to that, level by level, we can see which of them are introduced for the first time in each level. For example, in Danger Lane, we have 13 new interactions. Since it's an early level, everything is new to the player, so it's common for many interactions to appear here. From then on, the subsequent lists don't show interactions that have already appeared, and we can see where each interaction first appears during the game. For example, we know that in Level 2, the player has their first contact with the axe. Similarly, we can see that the last level doesn't present anything new to the player, which could be intentional, as it's the moment to challenge everything the player has learned. However, if that wasn't the developer's intent, this tab allows for quickly visualizing if any level isn't introducing anything new and how long the player goes without encountering new content. Just like in the previous tabs, in the list of each level, you have quick access buttons that lead to scene data, the reference scene, the link in the browser, and the button that leads to the level breakdown, which we'll talk about now. The Level Breakdowns tab provides detailed information about each of the levels in the game. By selecting a level from the drop-down menu or navigating using the navigation buttons, the data extracted from the corresponding scene data is displayed. So, by selecting the first level, we can see its number and quick access buttons. We also see a preview of how the estimates are distributed based on their zones, including intensity, time, experience, and economy. Additionally, we can quickly see if they are below, above, or on average compared to other levels. In addition to the preview of the zones, we can see 3 fields of information. The level interaction resume shows all the interactions present in that level and the values they generate in a clear and objective manner. For example, we can see that we have 9 enemies with pistols, and this cluster of enemies is generating an intensity of 45, 1.5 minutes of gameplay, 45 XP, and 45 economy. By hovering over these values, you can see the calculation being made to reach those results. We then verify that the number of enemies is multiplying the base value of the pistol-wielding enemy's interaction data. Just like in the other tabs, we can collapse the category tab for better visualization. Below each category, we see the total that category is contributing to the estimates for that level. Now, switching to the next level, as you can see, we have values in yellow. This means that these values have been influenced by an override or multiplier, and that's why they are highlighted here. If you want to check what's going on, you can simply use the Interaction Finder button. The level will open, and the Interaction Finder will open as well. That way, we can see exactly where these values are being generated. Here we can see that I used override values to define how much time the player will walk through the level in each of the zones. So you can quickly review these values this way. Alright, now let's go to the resume zone charts. Here we can see graphs similar to those we saw in the Game Progression tab, but focused on the zones of the levels. So we can get a breakdown of intensity, time, XP, and economy focused on each of the zones, allowing us to see where the peaks or valleys of estimates are and check if they align with our intentions. Finally, we have the level interaction detailed. Here's a more detailed version of the level interaction resume, where we can see which interactions are associated with each zone and also see how many of them are used and how they influence intensity, time, XP, and economy. Very well, with that, we've finished our tour of the breakdown windows. Now that you have everything set up to make the most of level breakdown, here are some best practices and tips for extracting the most from the tool in your project. The first tip is about version control. If you're working on a medium or large project, you're most likely using some version control tool. Therefore, it's very important to pay attention to the files generated by the level breakdown. Usually, you'll encounter these files: category data, interaction data, scene data, scene list, persistent data. All of them should be sent to the team so you can share the updated information you've generated. When using the Update Values option, it's very common to encounter changes in the interaction data, scene data, and persistent data files. In case of conflict, don't worry. Except for interaction data, which are values you manually change, both scene data and persistent data can easily recover their values. So there's no need to worry about resolving these conflicts. Once the conflict is solved, just do another Update Values and retrieve your values. The scene data will extract its values from the levels that are configured, and the persistent data will extract its values from the scene data collection in the scene list. If there are conflicts with interaction data, you should check with your team members, the people who made the changes, to ensure the correct version. Use prefabs. The tool becomes even more powerful when paired with prefabs. Link interaction objects directly to prefabs of interactions you've registered, such as enemies, NPCs, doors, and chests. This avoids the team from having to manually configure references for each element in the scene. This way, the only adjustment needed will be to define the zone for each object, if you're using this feature. Also, this approach makes it easier to replace or add multiple interaction objects in a single prefab, ensuring consistency and speed in development. Always remember that you can add as many interaction objects as you want to the same prefab. Create more categories for greater detail. Defining more specific categories helps organize and better detail the information. For example, instead of having just one category called rewards holding more general interaction data, you can further subdivide it, breaking it down into rewards, potions, and weapons. This way, you can analyze both the total number of rewards and more specific information, like how many laser weapons exist in the game and where they're located. Use interactions to track important systems. Although the tool was created to monitor interactions visible to the player, it can also be helpful for assisting in development. Consider creating a category for important systems by adding interactions to track achievement triggers, specific sound systems, AI events, or other relevant mechanics. This can help in debugging and locating systems in the game. Present the tool to your team. The level breakdown was designed with game designers in mind, but other members can also benefit from using it. The narrative team can easily navigate through levels using the centralized game progression view. The programming team can quickly find documentation for an enemy through the illustrated summary of the game breakdown. The art team can filter which levels have a specific biome through the activity overview. Just be creative and register relevant interactions for your project. Track the player's movement within the level. If your game involves movement across the map, consider creating a specific interaction for movement. This is essential for accurately estimating the level's time, as you can't just count the challenges the player faces. To use zones or not, that is the question. The need to use zones, multipliers, and overrides varies depending on the project and the team. Before deciding, discuss it with the people who will configure and use the tool. This feature provides a more detailed level of information, but it may require a bit more maintenance. The ideal is to find a balance. Be flexible with configurations without aiming for extreme accuracy. Remember that values are estimates, directly influenced by the player's behavior. Use the tool as a thermometer to assist with decisions, but never as an absolute truth. The goal is for level breakdown to facilitate game development and analysis. As mentioned before, the level breakdown is an independent tool designed to enter and exit your project whenever you want, without causing any issues. However, if at any point you feel the need to remove it from the project, there is a simple way to do that. Just go to Tools, Level Breakdown, Remove Tool from the project. When you choose this option, the tool will scan each level and prefab and remove references to interaction objects. But be careful. This action should only be used if necessary, as it will likely take a considerable amount of time, especially depending on the size of your project. This is also an irreversible action, meaning if you're not using version control, you won't be able to undo it. And that's not all. When you acquire the level breakdown, you unlock all the features of draw charts for free. With it, you can create custom charts directly in the Unity editor, just like the ones you saw in level breakdown. Expand your analysis tools and visualize data clearly, developing solutions as powerful as level breakdown. All the details about this tool will be in the documentation under Assets, Level Breakdown, Draw Charts. More control, more insights, and no additional cost. Well, if you want to optimize your level design and make your team's work easier, Level Breakdown is the right tool for you. The link to download is in the description. Don't forget to leave a like, comment on what you thought, and subscribe to the channel for updates on the tool. See you around.